Hey guys, so for our last week of remote learning, or the last 2 weeks rather, we're going to be focusing on right triangle trigonometry. What? Trigonometry! I said I would try to make this fun. I'm going to do my best. So, what do you already know about this triangle? Pick one of the true statements from the list. All right, here's some facts that I came up with about this triangle. We know about every single triangle that it's going to have three interior angles that add up to 180 degrees. In this case, one of them's 90. Okay. We also know this is an isosceles triangle because two of the sides are the same length, 7 and 7. And then we also know that the angle measurement in this triangle is going to have 45, 45, 90 because the two legs are the same length. So I also know actually the hypotenuse too, because remember we did special right triangles. And so the hypotenuse is going to be 7 times the square root of 2. So you could have that as a fun fact too. All right. So then in general, what do you already know about any kind of right triangle specifically, not just the special ones? All right, cool. So obviously they have a right angle, duh. And also something that you've learned in other math classes that I know y'all are already good at is Pythagorean theorem. So just to remind you, that's going to be that a squared plus b squared equals c squared. Okay, and that's going to be to help us find the missing side of a triangle, but we have to have two of the sides first. And so we're going to see why right triangle trigonometry is important because we might not always know two out of the three sides. Okay, so I'm going to use these special right triangles that we've already looked at to build up the idea of trigonometry. We've got three big new vocabulary words that we're going to learn relationships for. So this triangle is a 30, 60, 90 right triangle. I know that because they've labeled one of the angles as 60 degrees. Okay, I also know that the 8 is the short leg and the 16 is the hypotenuse, and that in this kind of special right triangle, if you take the short leg and you multiply it by 2, you're going to get the length of the hypotenuse. Okay, I also know how to find the third side without using Pythagorean theorem because it's a special right triangle, and I know that that other angle is 30 degrees because 60 plus 90 plus 30 degrees adds up to 180. So I pretty much know everything there is to know about this triangle, but I want to show you something pretty cool. So from our reference angle, which literally just means the angle that I'm talking about, of 60 degrees, I have this special relationship. It's called cosine. That is part of trigonometry. So what the heck is cosine? Cosine is a relationship between the adjacent leg. Okay, let's find that adjacent leg right here. So adjacent means next to. So adjacent leg has to be next to that 60-degree angle. Over, since it's a ratio, it's divided by the hypotenuse. You guys already know what the hypotenuse of a right triangle is. Has to be across from that 90-degree angle. So if I set up a relationship by putting the adjacent leg on top and the hypotenuse on the bottom, I get this super special relationship that's exactly 1/2. But what if the angle wasn't 60 degrees? Would I be able to get a relationship that's exactly 1/2? I don't know. That's what we're going to explore with trigonometry. Let's look at another example. Hey, guess what? It's the same triangle, but this time we're going to look at the 30 degrees, and that's going to be our reference angle. So from that bottom right corner down there, let's set up a relationship between the 8 and the 16 again. This time, instead of using the adjacent leg, I am now using what is called the opposite leg. Opposite just means across from, um, and so this leg over here that is 8 is going to be the opposite leg now. So it used to be the adjacent leg because I was looking at the angle right next to it. Now I'm looking at the angle that's across the triangle, so it's going to be called the opposite leg instead. And then guess what? We still got that hypotenuse on the bottom, and we know that 16 is the hypotenuse. So here's another special relationship, pretty cool, and that is sine. The sine is always going to be the opposite leg over the hypotenuse. All right, let's check out the last trigonometric ratio. We've got cosine and sine. Here comes the last one. We're going to go back to that first triangle we were talking about, and it's got 7 and 7 on the side. This is a special right triangle, 45, 45, 90, and I'm going to look from my reference angle of 45 degrees. Okay, if I were to set up a relationship for this one that had the opposite leg on the top of a fraction and the adjacent leg on the bottom of the fraction, what would that fraction be? Yeah, that's right. And so technically, this 7 is coming from the 7 on the bottom because it's opposite from the 45 degrees. And then this 7 is coming from the adjacent leg or the leg right next to the 45 degrees. And so when that reduces, we get 1. That's a really cool relationship too. And so for this one, the tangent is always going to be related to the two legs, the opposite leg over the adjacent leg. And I'm not using the hypotenuse at all. Okay, so I wanted to show you that these relationships are special because we've learned about special right triangles. So check this thing out. I linked this in Google Classroom so you can play with it too if you want to. All right, I started with a special right triangle here, and you're noticing that the cosine of 60 degrees over here on the side is exactly 0.5. There's that 1/2. But let's say that I were to make, I don't know, maybe this angle a little bit smaller. Let's drag it down. Okay. When I get to 50, now all of a sudden I don't have a special relationship that's 1/2. It's like 0.64, and that's rounded off. And then my sine also isn't really very special looking. So how am I going to remember every single relationship for every single triangle? Well, guess what? You don't have to because your calculator does. So we're going to learn how to do that in the next session. Let's keep on dragging. What if I go down to 45? Now I'm going to add in my tangent. So there's the opposite leg over the adjacent leg, 3 over 3, which gives us that fancy 1. But is that 1 always going to be tangent? No, it's only 1 because we're in a special right triangle of 45 degrees. So let me drag it on down a little bit more and we'll check out the tangent of 38 degrees. Now all of a sudden, all these ratios are completely random. Now I know how to set them up because I know that the sine is going to be the opposite over the hypotenuse. I know the cosine is going to be the adjacent over the hypotenuse, and I know the tangent is going to be the opposite over the adjacent legs, but I don't need to memorize all of these relationships for every single degree measurement. That would be crazy. But those relationships do exist, and they are going to be different for every single triangle based on the degree measurements. That, my friends, is trigonometry. Okay, so let's look back. If you were given this on a test, based on the knowledge that you have right now, could you find both of the other missing sides of the triangle? Probably not, because the only measurement they gave you is the 11, which is the hypotenuse. And it's not a special right triangle, it's only 52 degrees in one of the angles. And so I don't really know how I'm going to find the other two missing sides. That is where trigonometry is going to come into play. We can set up a relationship between the lengths of two of the different sides as a ratio, use the 52 degrees, and let our calculator go to work for us. So we're going to talk about the calculator part more in our next session, but for now, we're just focusing on can we memorize these relationships and practice setting them up. All right, so let's do this. First of all, memorization trick. How do you say this? It's called Sohcahtoa. Sohcahtoa. I don't know. It reminds me of a couple different things. You come up with something that helps you remember. But what does it stand for? Okay, so the sign is your S in so, and the OH is helping you remember how to set up that relationship. It has to be the opposite side or the opposite leg over the hypotenuse. Then you got your cosine. C is for cosine. This one you have to say ka. You can't say co, you have to say ka. And it's got that A in there for adjacent. So the cosine is the adjacent over the hypotenuse. And then finally, you got T for tangent. And tangent is related to TOA. That's how I'm going to remember it because it has the opposite on the top and the adjacent on the bottom. And those are both legs of a right triangle. I'm going to keep this picture on every slide for now so that you can use it when we're practicing, but this is something you are going to have to memorize when you get to Math 3. If you already know it, you're going to be ahead of the game because they're going to expect you to have seen it with me during remote learning. All right, so let's check out an example. What ratio would be the sine of A? Okay, wait a second. So A is my reference angle. So where am I even looking right now? I'm looking right here in the corner. I don't know what the degree measurement is, but that's my reference angle. Okay, then sine. What was this sine thing again? Okay, I have to use the opposite leg over the hypotenuse. So I'm going to go to the opposite leg, which is 10. That's going to go on the top of a fraction, top of that ratio, and then I'm going to use the hypotenuse. Now, they probably should have given you a right angle right here so we don't have to assume, but that 26 is going to be my hypotenuse. Now, I would love for you to reduce these fractions, but I'm going to leave them as is because I want you to be able to see where they come from when we're looking at all of these examples. All right, now it's your turn. How in the world am I going to find the cosine of A? I'll give you a helpful hint. The cosine of A is going to come from the adjacent leg and the hypotenuse. If the 10 was called the opposite leg, which one is the adjacent leg? Go ahead and put that one on top, hypotenuse on the bottom, and see if you can get it. Okay, good. That ratio is going to be 24 over 26. All right, finally, let's check out tangent. So remember, tangent is going to be the opposite over the adjacent, and those are both of the legs. Now we've already identified the opposite leg, and now we've talked about the adjacent leg. Put them together. Which one of these ratios is right? All right, so 10 over 24 is the relationship for tangent if I'm looking at reference A. Okay, perfect. Now let's do it all over again, changing our reference angle. That just means I'm not going to look at angle A anymore. I'm going to look at angle B. So if this is my reference angle and I'm starting up here in the corner, let's label the sides. Guess what? The 26 is still the hypotenuse. You can't change the hypotenuse of a right triangle. It's always across from the 90-degree angle. But what it does change is that the 24 is now called the opposite side. And the 10, this leg right here, is literally next to angle B, so it's going to be called the adjacent side. Now that I've labeled opposite and adjacent for you, how would you set up a relationship for sine of angle B in this triangle? Okay, good. The sine of angle B is the opposite, 24, over the hypotenuse, 26. What about cosine? Set me up a fraction for that. Okay, good. The cosine is going to be the adjacent side, which is now 10 over the hypotenuse, 26. And finally, what about tangent? Okay, cool. The tangent is the opposite, 24 over 10. Very good. Hey, let's try it one more time and we're out. What about this triangle? Now I left the sine, cosine, and tangent shortcut cheat sheet down here in the bottom corner. I want you to set up a relationship for the sine if my reference angle is 38 degrees. Did you get it completely on your own? That's pretty impressive. So if 38 degrees is right here and I need to find the opposite side, I have to look across the triangle from that. The opposite side is going to be the 25 feet. And so my relationship for sine is 25 on top and the hypotenuse is labeled x. I don't know what it is. What about the cosine? Okay, awesome. If you got that one, then you know that this 40 right here is called the adjacent leg. And so you would put that 40 on the top. We still don't know that hypotenuse, so the hypotenuse on the bottom is x. And finally, how about the tangent? Okay, good. We got that opposite side and that adjacent side labeled, so we are good to go. Opposite is 25 over adjacent is 40. Good job. All you have to do now is keep practicing these relationships until you have them memorized. Sohcahtoa. Have a great day, guys.